My name is Samar Saxena, and I'm a screen reader user, and I will be an upcoming first year at UNC Charlotte. I will be majoring in computer science, and for that, I took a bunch of college level high school classes like AP Calculus, AP/BC, and AP Statistics. And while I was doing the calculations, I found that while Desmos was a well-known solution, I found that the Microsoft Excel worked better because there are a lot of things that you can't do in Desmos, and I also thought that Microsoft Excel was cleaner. So today I will be showing you how to do a 95% confidence interval using Microsoft Excel. The question is that a statistics student wants to estimate the mean number of hours that college students spend sleeping during exams week. She collects 12 students in a random sample and records the number of hours each of them slept the previous night. To solve this problem, first you have to check the conditions, but I will not be showing you that here for the sake of simplicity. But I will link a video that will show you how to do those conditions. You wouldn't be doing them in Microsoft Excel anyways. You would have to do them by hand. The
Task
first
switching. Excel from Math. Book 2-Book 2.
So I have a blank Excel workbook document. And the first step is to get the data, which I already have in this document.
Blank, B2.
So our data is in column A. To solve this problem, first we need to find the sample size. There are two ways to find the sample size. The first is that that's already given in the problem because it says that there's a random sample of 12 students. So we could just write 12 in the edit box, or we can have Microsoft Excel calculated. I prefer having Microsoft Excel calculated. The way we will do that is that first, I like leaving two columns empty between the data and all the calculations. So we will move to column D, and we do that by right arrowing.
Blank, C2, blank, D2.
And then I will up arrow to cell D1.
Blank, D1.
And here I will type N, which stands for sample size.
N, edit. N, type in text.
And then I will hit enter to go down to cell D2.
Enter, blank, D2.
Here I will note that you can also put the, you can also do this column by column, where you have N and all of the other things that we will be calculating in one column and then the numbers in the next column. I prefer to do it this way, where we have the thing that we're calculating in row 1 and then the equation in row 2. So we have, we're calculating sample size. To do that, we just count the number of data we have. To do that, we use the function count. To write any function in Microsoft Excel, we have to first write equals. So that's what I will do.
Edit, equals.
And then we type count.
C-O-U-N-T.
Open parenthesis.
Left parent.
And then you have to give it the data range that you want to count, which for that you have to type the first cell that has data, colon, and then the last cell that has data. So in this case, it will be A2 colon A13.
A, abs, 2, colon, A, abs, 1, 3.
And then we write close parenthesis.
Right parent.
And then enter.
Enter, blank, D3.
So next we need to find the sample standard deviation and sample mean. First we calculate sample standard deviation in column E.
Blank, E3.
So I will arrow up to E1.
Blank, blank, E1.
Here I will type sample standard deviation.
SAMPLE space STANDARD space DEVIATION.
In the next cell, in cell E2, we will calculate the standard deviation.
Enter blank.
For this, we write equals,
Edit equal
and then the function name is stdev,
STDEV
period,
S
s, open parenthesis,
left parent
and then that same data range of A2 colon A13,
A abs 2 colon A abs 1 3
and then close parenthesis.
right parent
Lastly, we write enter,
blank
and then the next thing that we need to calculate is the sample mean, which we will do in column F.
blank F3 blank F
So I write sample mean in cell F1.
SAMPLE space MEAN. Enter blank.
And then in F2, we write the formula, which will be equals,
Edit equal
average,
AVERAGE
open parenthesis,
left parent
and then the data range of A2 colon A13,
A abs 2 colon A abs 1 3
close parenthesis,
right parent
enter.
blank F3
Then in column G, we will calculate degrees of freedom.
blank G3 blank G1.
So in cell G1, I will write DF, which stands for degrees of freedom.
D at F D F.
And then I will press enter to go down to cell G2.
Enter blank G2.
And then equals.
Edit equals.
And then the formula for degrees of freedom is just sample size minus 1. So this will be D2 is the cell that we're storing sample size in. So that I will write that.
D date 1 of 33 2
minus
dash 1. Enter blank G.
If you don't remember what the cell is, then you can also arrow to it. So what you would have to do is that if you start typing the formula and you don't remember which cell the sample size is in, you press escape to get out of the edit box. Actually, you wouldn't do escape. If you do escape, it won't save what you have written. So just press enter. And then you can use your arrow keys to find the cell that you stored sample size in. So when you go to a cell, what JAWS or any other screen reader says is that reads the contents of that cell. And if that cell doesn't have any contents, it will read empty. And then after that, it will tell you what the cell is. So like D1, D2. The next thing that we need to calculate is the critical t-value. So I will go to the right to column H.
Blank H3.
And then I will arrow up to cell H1.
Blank H1.
Here I will write critical t-value.
CRITICAL space T dash VALUE.
And then I will press enter to go down to cell H2.
Enter blank.
And then here we will write the equation to calculate the critical t-value. So equals.
Edit.
And then this formula is T
1 of 35.
Period. INV. Period.
2 T.
2T. I'm pretty sure that if you just type T here, then that will give you the one-tailed t-test instead of the two-tailed t-test. But right now we want the two-tailed t-test because for the critical, for the confidence interval, it's the middle part that you want. So the two-tailed t-test will give you stuff on both sides, left and right. So we have this formula, then we write open parentheses.
Left parent.
This function takes two values. One is your confidence level and the other is the degrees of freedom. Again, we're calculating a 95% confidence interval, so the confidence level is 95%, but we can't just write 95% here. So what we do is that we take 100%, subtract 95% from that, so that gives you 5%, and then you take 5% as a decimal, which is 0.05. Basically, you need to pass how much of the data you want on both sides, which is 5%.
0.05.
And then we type comma to tell it that the next thing is the next argument, so not the confidence interval, but the degrees of freedom.
Comma.
And the degrees of freedom is in cell G2. So that's what we type here.
G2.
Close parenthesis.
Right parent.
And then enter.
Enter. Blank. H3.
If you don't press enter, if you press escape, then again, it will not save your the thing that you're trying to type. Then we go to column I.
Blank. I3.
Arrow up to cell I1.
Blank. Blank. I1.
And then here we're going to calculate the standard error.
STANDARD space ERROR. Enter.
As a refresher, the standard error formula is the sample standard deviation divided by the square root of the sample size. So for that, we type equals.
Edit. Equals.
Sample standard deviation is in cell E2.
Edit 2.
Divide by is just your /, just like in Desmos.
Slash.
And then for square root, this one is also going to be a function. This one is going to be SQRT.
SQRT.
Open parentheses.
Left parent.
And in the parentheses, you type what you want to take the square root of. Right now, we want to take the square root of the sample size, which is in cell D2.
D2. Right parent.
You could also just type 12 since we know that the sample size is 12.
Enter. Blank. I3. Contains formula. 0.2 blank. I3.
Now we arrow over to cell column J.
Blank. J3.
And we arrow up to cell J1.
Blank. Blank. J1.
And here we're going to calculate the margin of error.
MARGIN space OF space ERROR. Enter. Blank.
And then we press enter to go down to cell J2. The formula for margin of error, again, is the critical t-value times the standard error. So that will be equals.
Edit. Equals.
Critical t-value is in cell H2.
H. Harmian 2.
Then we have, for multiplication, is the asterisk symbol.
Star.
And the standard error is stored in cell I2.
I2.
If you were to type J2 here by accident, since we're working in cell J2, it will give you an error. So just be careful about that.
Enter. Blank. J3.
Then we go to cell column
Blank.
column
K3.
And now we're going to calculate the confidence interval, which has two parts, the lower bound and the upper bound. We cannot calculate both at once. So first we're going to calculate the lower bound in column K, then we're going to calculate the upper bound in column L. So we go up to cell K1.
Blank. Blank. K1.
Here we write confidence interval lower bound.
CONFIDENCE space INTERVAL space LOWER space BOUND. Enter. Blank.
And then press enter to go down to cell K2. The formula for confidence interval is the sample mean plus or minus the margin of error. For the lower bound, since we're calculating the lower portion, this will be subtraction. We will be doing subtraction on the cell. So this will be equals.
Edit. Equal.
Sample mean is stored in cell F2.
F2.
Minus.
Dash.
And then the margin of error is in cell J2.
J2.
And then press enter.
Enter. Blank. K3.
And then we arrow over to column L and go up to L1.
Blank. Blank. Blank.
Here we type confidence interval upper bound.
CONFIDENCE space INTERVAL space UPPER space BOUND. Enter. Blank. L.
And then press enter to go down to cell L2. Then in cell L2, we calculate the upper bound, which will be the same thing that we did in cell K2, but it will be plus instead of minus.
Edit. Equals.
So this will be equals F2, which is where our sample mean is.
F2.
Plus. J2 is where our margin of error is.
J2. Enter. Blank.
Okay, so now we have the answer. We can use arrow keys to read what it is. So I do left arrow to go to cell K3.
Blank. K3.
And then up arrow to cell K2, which is the number that we have for the lower bound.
4.7. K2.
So the lower bound of our confidence interval is 4.7. And then we right arrow to go to cell L2, which is where the upper bound is.
6.1. L2.
So the upper bound of our confidence interval is 6.1, which means that 95% that we are 95% confident that the population mean is somewhere between 4.7 and 6.1. Okay, thank you for watching my video, and I will see you next time.